NX CAM Robotics programming enables you to bring an industrial robot into your NC setup as a machine assembly. Retrieve the machine from the library as always and use the robot class to choose your machine. Several commonly used robot models are provided with the NX CAM library of example machines, and these are easily customized with the NX CAM machine tool builder as needed. Bring the machine into the setup, taking care to mount the part on the machine, and the machine will move relative to the part according to the kinematic model of the robot. The robot may contain external axes as well, such as travel rails or part positioners as seen here. As with any machine model, your robot assembly model may be as detailed as you like, including the entire work cell if desired. We'll concentrate just on the robot and work positioner. The presence of the machine in our setup means that we can perform machine simulations, in this case a robotic simulation. Notice the excessive head rotation as the robot follows the zigzag toolpath. We'll eventually correct this by editing the robotic machining rules to control the head orientation. Industrial robots are 6-axis machines, so they have more than one solution for a particular location. The part positioner in this case is yet another axis of motion. We will need to provide some instruction to the software in order to obtain our preferred solution. We'll do that using the robotics rules, which are unique to the robotics programming environment. We'll edit the robot tool orientation rule and change the orientation mode from tangent to a fixed orientation. The tool, or the robotic end effector, has a large offset on it that we want to prevent swinging around, so we'll specify that the tool stay aligned with the edge of the part clamp. These robotics rules are applied to the finished NC toolpath in order to specify our preferred robotics positioning solution. So after modifying the rules, we apply the rules to the toolpath and simulate again to see the new motion. As the simulation starts up, we see that the head motion looks much better. We're triggering a singularity warning in the robot's 5th joint called J5. As we continue, we see there are some over travel indicators as well, shown by the red robot members, but the part positioner is not moving at all. We should get the positioner involved in the solution so that the robot can stay positioned higher and not bend so low that it over travels. We'll edit another of the robotics rules to achieve our preferred robot positioning. The positioner rule is set at a constant joint value, so it's staying still. We'll change that to constant surface normal to request that the surface normal at the cutting position stays oriented vertically along Z. Now we apply the rules again and see the new motion. This is much better, and we're ready to proceed. The robotics programming software has provided us with the means to include a 6-axis industrial robot into our machine environment and provide additional position rules to achieve our preferred robotics positioning solution, all in NX. Post-processors are available as well, ready to send production-ready code to your robot cells.